Alrighty, key features of functions. This is super bright pink, so I must have been really excited when I made this or something. I don't know what was going on. But anyways, so domain, range, blah, 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 blah. All of these we are going to get throughout the unit. Okay, we'll get definitions of each of these. Okay, like right now. So a function is a special type of relation in which the element of the domain is paired with a unique element of the range. Okay, so the domain is usually like your x values. The range is what you plug in to your function and get out from those x values, so it's our y values. Okay, so the domain is the input values. That's what we're putting in. And that's what you think like left to right when you're looking at graphs. Range is your output values, so that's your y values. And that's what you're getting out, and that's bottom to top. Okay? So if we look at this, we want to give the domain and range of each relation. So this first one, first we need to get into this. So we have brackets and we have parentheses. Parentheses means that you do not include them. Okay, that means that like it's an open circle there, or there's an asymptote there, or it means that there's not a point on the graph right there. The brackets means that there is a point. Okay, and you have to include it. Okay, on infinities, it is always negative and positive infinity. Every single time. Well, no, that was a lie. I just lied to you. I didn't mean that it's negative infinity and positive infinity all the time. I meant that it's always parentheses. Okay, every single time you have infinities, you use parentheses. Sorry about that. Now, domain. So you go left to right. So here, the furthest left point we have is a 4, and it's a parenthesis because it's an open circle there, so that means that we don't have a point there. Then we keep going, and we get to 1, and that's a closed circle, so that means that there's a point, which means there's a bracket. Okay, range, we're going bottom to top. So the furthest bottom we go is, dang it, -7, sorry. Whoa. That's not what I wanted. -7, sort of. That looked really bad too. -7 and +2. So this should be -7 to 2. Okay, and we aren't worried about this because it's taken care of over here. So even though there's not a point there, there's a point there, so we don't care. Okay, because we're just going bottom to the top. Now this one, domain, that goes forever in the left direction, so towards negative infinity. Forever towards positive infinity, so that's negative infinity to positive infinity. Range is bottom to top, so the furthest down this goes is -4. And the furthest up this goes is +5, so that's going to be -4 to 5. The domain here is negative infinity to -1. And then anytime you have like a jump or something, that U means a union. It kind of stands for like and. So it goes from negative infinity to -1 and from -1 to infinity. Range, negative infinity to -2 and -2 to infinity. Okay? These ones, so domain on this one, negative infinity to positive infinity. Range is negative infinity to +6 with a bracket. Domain is 3 to infinity. Range is -4 to infinity. Domain is negative infinity to 3 and then 3 to infinity. And then negative infinity to 0 and then 0 to infinity. Cool? Now, intercepts. So intercepts are where they cross, where the graph crosses either the x-axis or the y-axis. Okay, so the x-intercept occurs where y equals 0. And the y-intercept occurs when x equals 0. Okay, and at most, the function can have 0 or more x-intercepts. So x-intercepts, you can have infinitely many x-intercepts. Like if you have a graph like this, and it goes forever, that's going to cross the right there, blah, 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 blah. Forever. Like you're just going to keep crossing it, okay? But for y-intercepts, you will only ever cross at one point. Okay, if it crosses at more than one point, it is not a function. Okay, so at most, one y-intercept. So if we look at these, we can just find these by looking at it. So the x-intercept there is 4, 0. The y-intercept is 0, 2. Our x-intercepts here are -1, 0, 1, 0, 2, 0, and 3, 0. So see, we have 4 x-intercepts there, but we only have 1 y-intercept at 0, 6. Here we have no x-intercepts. That is never going to cross the x-axis, but we do have a y-intercept at 0, 5. You will always have, oh, that's a lie. That was a big lie. There are times when you don't have a y-intercept. So if you had like a graph that looks like this, so this is a square root function. Sometimes you could have a square root function that goes like this. That's never going to cross the y-intercept or the x-intercept, so there's no intercepts there. Okay? Now finding them algebraically. So to find the zeros are a lot of time, these are also called the x-intercepts. So to find the x-intercepts algebraically, we're going to set f of x equal to 0 and solve for x. To find the y-intercepts, we're just going to plug in 0 for our x's. So if we have this, so f of x equals negative absolute value of x minus 5 plus 3. Well, we want to see where this equals 0. So where's this going to cross the x-axis? So 0 x-intercepts, we're going to plug in 0 for f of x, and then we're going to solve this. So I'm going to start by subtracting the 3, divide by -1, and I have 3 equals the absolute value of x minus 5. Now remember, with absolute values, you set it equal to positive and negative, so that's going to be x minus 5 equals positive 3, and x minus 5 equals negative 3. So x equals 8, and x equals 2. Sweet. Now for y-intercepts, oh yeah, and write them as ordered pairs. So 8, 0, and 2, 0. Now for the y-intercepts, we're going to plug 0 in. So that's going to be f of 0 equals negative absolute value of 0 minus 5 plus 3, which is going to be negative absolute value of negative 5 plus 3, which is negative. Absolute value of negative 5 is 5 plus 3, which is going to be negative 2. Okay? This one. So first we're going to find our x-intercepts by setting equal to 0. And you can do this with slip and slide. I don't think I did, so I'm going to just talk through what I did. Multiplies to be 8, adds to be negative 7. Well, that's going to be negative 8 and 1. So this is going to be 2x squared minus 8x plus 1x minus 4. Group those first two, group the second two. You can pull out a 2x from there, can pull out a 1 from there. So that's going to be 2x times x minus 4 plus 1 times x minus 4. Pull out that x minus 4, so that's x minus 4 and 2x plus 1. If you factor that a different way, totally fine. Then we're going to set both of those equal to 0. So x minus 4 equals 0, 2x plus 1 equals 0, so x equals 4 and x equals negative 1/2. This one, we're just going to plug in 0, and it's super easy when it's like this because those just cancel and you're left with negative 4. Sweet. I want you to try those next two examples. Okay? Now this one. So critical points, or like extrema is what they're called a lot. This is where the graph changes its direction or its shape. So there's two things it can change here. It can change its direction, so like which, is it going up, is it going down, whatever, or it's going to change its shape right there. Okay? So extrema, that's where it changes its direction. So that's like if you're going up, 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 and then you hit a peak, and then you go down, 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 down. Or you go down, 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 and you're in the depths of the valley, then you can go up, 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 up. That would be extrema, those max and mins. Okay? Point of inflection is where it kind of changes its shape, but it doesn't change its direction. So like you're going down, and then you hit a little flat spot, but then you keep going down. Okay, that's a point of inflection. So relative maximum, that is where it's not the maximum of the entire graph, but it's a maximum compared to the graph or to the points around it. Absolute is the highest on the entire function. Same thing with minimum. It's the lowest compared to the points directly around it, or it's the very, very lowest. Okay? So if we look at this graph, This has an absolute minimum at 4, -5. If you have a calculator, I'm going to go over this in class also, but pull it out and do this with me so that you can be ahead of the curve, okay? So click y equals in the top left and plug in the equation 2x squared minus 16x plus 27 and then click graph. And you should pull up this graph right there. It should look like that. Now, if yours doesn't look like that, click zoom 6. It'll fix it. And then we're going to find the extrema. So say that you couldn't really tell, like, oh, that's 4, -5. You could pull up your graph. Okay. So to find the extrema, you're going to click second trace and then go to minimum since this is a minimum. Okay. Now it's going to bring up like this little spider guy. For the left bound, you can see it right here. So this, you want it on the left of the low point. So this is the low point and we want it, here's our low point, we want it on the left of it. And then you're going to put enter. And then you're going to move it over to the right of it, right of the low point, and click enter. Okay, and then you're going to click enter one more time. And it will pull up the minimum of 4, -5. Cool? Okay. We'll do the other two tomorrow. If not, try to do them if you have a graphing calculator. If not, we'll do them tomorrow. Oh, I forgot I did this. Those are my puppies, and I just wanted a little break from math because, yeah, we all need breaks. And they're adorable, and I hope you love them as much as I love them because they're super cute. Her name is Aria, and she is a German Shepherd mixed with a Golden Retriever. And his name is Aldebaran. We call him Bear. Aldebaran's a star, like, in the sky. And he's adorable. He's a mini golden doodle, but he's actually a giant. I'm pretty sure he ate one of his brothers in the womb. That's very dark. I really hope he didn't do that. But he's huge. He's a lot bigger than all his siblings. So, yeah, anyways, I hope that made you smile because they make me smile and they're super awesome. Okay, let's finish this. So, moving from left to right, a function may increase, decrease, or remain constant. So increasing, think about like climbing a mountain. We live in Utah, so there's a good chance you've probably gone on a hike before. Increasing is when you're walking uphill, okay? And you're like, this is freaking hard. Like, what did I get myself into? Constant is when you're walking just straight and you're like, oh, this is nice. Like, I got a break. And then decreasing, you got to the top and you're coming back down, so you're walking downhill, okay? And you always think left to right. So this little purple guy, he's super cute. So he's increasing when he's walking uphill. So he's increasing from -infinity to -1, because that's when he's walking uphill. Then he's constant from -1 to 4, because he's just kind of chilling, just kind of walking along. And then decreasing, he's got to start running or something, or he's going to start tumbling from 4 to infinity. Okay, so if we look at this one, so you'd be increasing from 3 to infinity and decreasing from -infinity to 3. Here, you are never increasing. You are always decreasing, but except for at -5, because there's nothing going on right there. That's an asymptote. We'll get into asymptotes later and like where they come from, why they're popping up, blah, blah, blah. But that's an asymptote right there, okay? So it's decreasing from -infinity to -5 and then -5 to infinity. Okay, you can finish the rest of them. I will see you whenever I see you. Remember to take the quiz. Okay.